start talking about matrix right now in R, and let's see. So when you define a matrix in R or in anywhere in the world, it means that it has like m times n dimensions. So that means you have m rows and n columns, okay? So when you think about your data, you have your m subjects and n variables. So we can always define a matrix by using matrix command in here. And let's say you want to have this matrix from 1 to 3 and just give it a name. Generally we are using uppercase letters to define matrices in math, okay? Sorry guys, just define your matrix and you are able to see this is a column matrix in here, okay? If you want to change the dimensions of this matrix, just use matrix again, and you have your values from 1 to 3, and this time your number of rows is going to be 1, and your number of columns is 3. And now, when I change the dimensions for my matrix, now I have this row-wise matrix in here, row matrix, okay? And let's again generate my M matrix from 1 to 3, 1 and 3, just giving me the same. So I already know these options, the arguments in here. You can just write the names of the arguments or you can just get rid of them. And when you just check out for the class of M, you can see its matrix. And when you just see the type of M, and it's an integer. In here, class shows that this is a matrix in here, but type of just give you that fundamentally the matrix is an integer vector in here, okay? There are two other ways to see the type. Class shows M is a matrix, but also when you just type of, you will see it's an integer vector. The elements in that matrix are integers, okay? Is it clear in here? We also have another way to generate our matrix in R. Let's say I have my M from 1 to 20. Here is my M. If I give the dimension of M's, let's say 4 and 5, now I have my matrix 4 times 5, okay? 4 rows, 5 columns. This is another way. And also we have R bind, that means row binding, and C bind, that means we are column binding in here. And we can use these two functions just to bind your columns or rows to generate your matrix in here. A is my first vector from 1 to 5. Here is my A. B is my second vector from 11 to 15. Here is my B. If you R bind these two guys in here, you will see you have an even matrix right now, okay? And if you C bind your A and B, now R is going to column bind these two vectors in here. Also, you can always give it a name, M1, for example, and R bind A and B. And when you just write your M1, you will see that you have now 2 by 5 matrix in here, okay? And just check class of F1, you will see that it's a matrix. And you can always call it an array for one-dimensional. Okay, matrix and one-dimensional array in here. Any question? So we already have integer vectors A and B, and you can also generate a character vector. Let's say A, B, C, D, and E. And here is my new matrix in here. If you are bind all these guys, I have my A vector, B vector, and D vector. If I combine them, you will see that are converted, all of them, to what? I converted all the elements to what?
String.
What?
To string.
String.
These are characters right now, because for matrix, all your elements have to be the same kind. When you just check out for the class for this guy, M2, okay, it's a matrix, but the type of this matrix is a character right now, okay? So there is one thing in R that when you just generate your matrix, when it is filling that matrix, it just fill that column by column, okay? First column to second column to the rest. Let's see what I'm talking about. Here is my matrix from 1 to 6. When I say the number of row equals 2 and number of column, what it has to be right now? What should I write here? I have elements from 1 to 6. If my row is what?
3.
Yep, perfect. So I have my matrix, and it's just getting the elements from 1 to 6 and filling the matrix by column. First column, second, you see that 1, 2, 3, 4, 5, 5, 6. If you want to write the same vector by row, like 1, 2, 3, 4, 5, 6, you have to do something. Matrix. I'm going from 1 to 6. I have 2 rows, 3 columns. And if you say by row equals true, then it's going to do it by row, filling the elements by row. You see that? 1, 2, 3, 4, 5, 6, different than the before, okay? Any question? So please remember my M matrix, okay? And if you want to see the dimension for this guy, just write dim M, and you will see that the M has 4 rows and 5 columns, okay? You see that I have 1, 2, 3, 4 rows, and this is how you can index your rows, and you have your columns in here. And like, if you want to get the first row, you just add this index and you are able to get the first row. Okay, we will move to that topic. So you can easily subset your matrix in here because you know how to subset your vectors by indexing. And we can just do the similar job in here, but please keep in mind that different than vectors, which has just one dimension, matrix has 2 dimensions. Let's see what I'm talking about. Let's generate another matrix. Okie dokie. From 0.5 to 8.5. I have 3 and 3. Here is my matrix. Okay. I generated another A matrix by using matrix function. It is going from 0.5 to 8.5. That means I have 9 elements. And this is going to be 3 by 3 matrix for me, guys, okay? What is this? I don't need it. Okie dokie. So, I want you to do, get the second row of A from the third column. Here is the exercise, guys. So here is how we get first row. Here is how we get first column. And this is how we get the second row of A from the third column. And now we are going to find the first and the third columns in A. So if you want to get the first and the third columns in A, and here is how we have it. We just combine the first and the third one, okay? And deleting anything in matrix is similar to deleting in a vector. You remember we were using the minus indexing in here. For example, you want to delete the second row, let's say, just do that. And now we don't have the second row, okay? Or you want to delete the first row and the second column. Let's say you want to delete the first row and the second column. Okay, to delete, we are just, sorry, I have to add -2. We are just deleting these guys in here, okay? And please remember A matrix. This is 3 by 3. You can always replace some values in A. For example, for this guy, the second row and second column, I want to change this guy in here. I just choose by indexing and just, sorry guys. Just say it is 0. And when you just ask R to write A, you will see you just change it to 0, okay? And also you can change all the values on diagonals just using diag function. And here is 1. When you just check out your A, you will see after all your diagonal elements are 1s, okay?
May I ask something about the deleting part? Yeah, in the row 154, yeah, I could.
So we know how to do some diagonal elements in here. Also, we are able to do some matrix operations in R or matrix algebra. Okay, let's say you want to do some matrix operations. For example, you want to get the transpose of a matrix. I have A, this is my matrix, and R is really, really handy for in here. When you just write T, R is going to give you the transpose of your matrix, okay? And do you remember what was the identity matrix? Do you know what is identity matrix in here?
Isn't it the one with diagonal ones and everything else is 0?
Yeah, perfect. When you have ones on diagonals, and when you just say like my A, sorry guys, is diagonal 3, it's just generating a 3-dimensional diagonal matrix in here. The ones on diagonals and 0 everything else, okay? So we can also do some matrix addition and subtraction. I want to generate 2 new matrices in here, guys. Okay. I have my 1, 3, 6, 2, 3, 5. This is going to be 3 by 2. I have my B again. This is a matrix. Let's generate by writing you can just play with the numbers. It's up to you guys, okay? It doesn't matter what you are writing there. 4, 5, and this is also 3 by 2 matrix. I have two different matrix right now. A is 3 by 2 matrix with 2, 1, 2, 3, 3, 6, 5. And I also have my B. This is also 3 by 2 matrix with 3, minus 2, 8, 1, 4, 5. These values doesn't matter. You can just add anything you want in there. If you want to do some matrix addition, just use A plus B. And you will see it just adding your two matrix element by element. And if you want to do some, instead of addition, if you want to do some subtraction, just use A minus B, and you will just see that R is going to do your subtraction element wise, okay? So we want to do some matrix multiplication. If you are familiar with matrix algebra, you will remember that you have to have some matrix dimensions which have to be compatible for multiplication. Let's say what I'm talking about. I have my dim function to see the dimension of my A matrix, dim A. I have my B, and these two guys are 3 by 2. Are you able to do matrix multiplication with these two matrices? With these dimensions?
Evet
Yes.
hocam.
I think so. Okay.
I think no, we can't
We
because
can't.
No,
has to
last
be-
one's first one's last number and second one's first number has to match.
Yep. The dimension, the second dimension for A has to be the same with the first dimension of B. That means the row and columns, okay? 3 by,
Okay.
if it is like 3 by 2, then this has to be 2 by something. It doesn't matter, but the inside elements has to be the same. So how we can do that? We can just get the transpose of one of them. Let's say I want to have my B should be transpose of B. I'm overwriting, and I just check out my B. This is now 2 by 3. And let's see my dimension. Now I'm good to go, okay? But there are two ways you can do that multiplication, A times B or B times A. Which one is correct?
B times A.
Does it matter now? Let's see. When I have A
Doesn't matter.
times B, you see that I have my matrix multiplication now, or let's see if I can do these two. Yeah, I'm able to do both because now these two dimensions are compatible for multiplication in here. Okay. Any questions so far? If this is not clear for you guys, maybe it can be a good idea to check how we were doing this matrix algebra in math. Okay. So we can always get the inverse of a matrix in R.
Hocam çok hafif yavaşlayabilir miyiz? Not
Sure.
olarak gidiyorum da.
Sure. So you are trying to write the code with me, guys. And when I just check out the dimensions for A and B, they have to be compatible for multiplication. What I mean is that the column of the first one and the row of the second one has to be the same. Okay, they have to be same. And this is the sign for multiplication in here. Okay, this is the sign for that. Now I'm able to find the inverse of a matrix. Let's generate a matrix, and please keep in mind that it has to be inversible. And here is R bind. I will just, there's another way to generate a matrix. Let's say I want to have 2 by 2, and here is my matrix. I'm just generating matrix by row binding 2 vectors. There are several ways that you can generate a matrix. One of them is just to use matrix function, or you can just use R-bind function to R-bind your 2 vectors, okay? Here is my A. Here is my A matrix. This is 2 by 2, okay? And if you want to get the inverse of a matrix, you can just write sol A, and it just gives you the inverse. This is a function defined in R. It's easily giving you the inverse of a matrix in here. And here is, check out the result. If I have A times minus inverse A, I have identity matrix, as always, okay? Is it clear, guys? Do you have any questions so far?